This video will be the first video of a series describing additional design details to wood-turned Pysanky eggs. Over the years I've produced hundreds of these wood-turned Pysanky eggs, and now I'm looking to add some additional design details to the tops, bottoms, and sides of these eggs using a new automated Rose Ornamental Lathe. During the production of these videos, I designed several jigs to hold the eggs in position during the cutting operations on the Rose Engine Ornamental Lathe. These Rose Engine jigs to hold the wood-turned eggs will be described in future videos in this series. Here are a few of my first attempts at adding some design elements to a few of these wood eggs using a Rose Ornamental Lathe. Many additional examples will be shown in future videos. This first example is a very simple pattern in which I use the Rose Ornamental Lathe to add designs to the top, the bottom, and both sides of this wood egg. I then produce some more elaborate patterns. On this last example, I used one of the multi-layer discs, which will be described later in this video, and inserted it into the cavity in the wood egg. The cavity for this insert was cut on the Rose Engine. But before I begin, I first need to evaluate and determine the parameters that I'll be using to design and produce the designs on these wood-turned eggs. Parameters such as which rosettes I'll be using, what types of wood species I'll be using, and the various operational parameters on the Rose Engine need to be determined. This video will describe my evaluation of these and many other parameters for the production of designs on these wood-turned Pysanky eggs. Here's a list of the various parameters that I'll be evaluating and describing in this video. I currently have at least 20 different rosette patterns. I designed these rosette patterns using the Fusion 360 software and then printed them out using my 3D printers. I also have used 4 different cutting tools for my ornamental lathe. I'm using all direct drive cutting tools. I have not used any of the overhead drive belt-driven systems. I feel that by using these direct drive systems I get less vibration and therefore smoother cuts when using these systems. The first cutting tool that I designed and produced is a universal cutter, which I described in a previous video. This cutter uses a fly cutter to produce some longer cutting patterns. I use a spindle motor for most of the cutting for this video. This is an air-cooled spindle motor with a maximum speed of 12,000 RPM, but I normally only need to operate the system at between 6,000 and 8,000 RPM. I did not find any advantage of higher speeds, which can cause wood burning issues. Before I purchased a spindle motor, I used a ram rotary cutter, which can operate at speeds of over 20,000 RPM. But I've also used the Dremel tool in my initial testing. However, I'm now using the spindle motor for most of my cutting operations. Next, I wanted to evaluate different wood species. Several other Rose Engine operators reported that they need to use very tight-grained woods such as blackwood or ebony to get optimum results. I wanted to test this further. Therefore, I wanted to test some close-grained woods such as ebony and cherry, as well as several open-grained woods such as oak and mahogany, as well as a variety of additional woods for this study. I also wanted to evaluate the cutting designs on flat surfaces as well as on curved surfaces, such as the curved surfaces of the wood-turned eggs. In addition, I wanted to evaluate the effect of wood grain on the appearance of the cut design patterns. I also produced some multi-layered wood samples. These multi-layered wood samples produce more visible patterns when they are cut in the Rose Engine. I used my Accu-Slice system to slice some thin layers of various contrasting colored woods. The thickness of these wood layers vary between 25 thousandths and 50 thousandths of an inch thick. I then glued several of these thin wood layers together using epoxy cement to produce the multi-layered wood disc. In addition, I wanted to determine the best cutting tool bits to use, the depths of the cuts, and the speed of cutting. I want to develop cut patterns with smooth cutting surfaces, and I want to eliminate any splitting or chipping of the wood samples. In order to evaluate these parameters, I produced more than 50 wood discs, which will be turned on my automated Rose Ornamental Lathe. These wood discs varied between 2 and 3 inches in diameter. The wood discs were cut from a variety of wood species, as well as the multi-layered woods. I produced a variety of patterns using my Rose Ornamental Lathe. I used different rosettes, different cutting tools, and other parameters in order to evaluate the features described above. Here are the design patterns that I produced with each disc on the Rose Ornamental Lathe. First, let me demonstrate how I produced some of these patterns on my automated Rose Ornamental Lathe. Afterwards, I'll describe the results using these design patterns. This study will provide me with a wide range of ideas that I can use for the production of designs on the wood-turned Pysanky eggs. I use two different ways to mount these discs to my Rose engine lathe. Both of these discs were printed with my 3D printer. This one contains a thread which screws into the thread adapter on my system. And this adapter plate just has a 3/4 inch diameter hole which mounts directly onto the spindle. Then I use double-sided tape on my wood samples to attach the wood to the disc and then attach it to my spindle on my system. This one I would put my spindle on there, and then this would screw on in its place. And then mount it with double-sided tape. Now, this is a special faceplate I printed with a 3D printer. It has a thread to mount on my Pysanky lathe, and it also fits the Rose machine. It's much like a faceplate, but except it's perfectly flat on the side. And I put these holes in here which are all tapped, so there's set screws in there. So I'll be attaching my wood with double-sided tape, and when I want to get it off, I can just push those set screws in, and that'll push the wood away from the double-sided tape to release it. So that's how that's done. So and then it gets attached here. And so I'm doing now, I'm rounding this up to give me a round dome. Then I'll put it on my Rose machine and do the decorating. I had created these face plates with a 1 1/4 by 8 threads per inch thread, so I can turn the curved surfaces of the disc and then transfer this plate with the rounded disc to the Rose Ornamental Lathe to do the final designs on the curved wood surface. This face plate will also be used for other projects in the future, since they can be used both on my Pysanky lathe as well as the Rose Ornamental Lathe. I'll be speeding up this video 10 times the actual cutting speed and editing this demonstration video quite a bit for this section to reduce your viewing time. Normally it takes at least 30 minutes or more to print a pattern. For this first example, I'm cutting a multi-layer disc using maple for the top surface and a padauk underlayer. I like using these multi-layer woods because they enable the viewing of more complex and smaller design patterns. As the cutter penetrates past the top layer, it then exposes the underlayer. I'm using a sharp pointed cutting tool with 2 cutting edges and operating the cutter at 6,000 RPM. For this example, I'm cutting to a total depth of 50,000ths of an inch in 10,000 inch increments. In other words, it takes 5 passes of the cutter to complete a cut layer. As each layer is cut, I'm stopping the spindle and rotating the spindle by half a phase before advancing the cutter outwards for the next cut. I've set this advanced cutting distance for each layer so that this next cut layer just touches the previous cut layer. Also notice that I did not cut the inner layers as deep as the outer layers. If I cut these inner layers deeper, the pattern created by the wide cutter bit would have been destroyed. For the final cut for this pattern, I stopped the rocking motion of the spindle head and just cut a circle around the inner design pattern. And here is the final cut pattern. I then sand the surface lightly using a floppy disc wheel. Here's just the last few minutes of cutting designs on a solid padauk wood block. The pattern was cut similar to the last pattern, with phasing between each layer, and each subsequent layer just touching the previous layer. This pattern was cut to a final depth of 60,000ths of an inch. After the cut pattern was complete, the surface was lightly sanded on a floppy disc wheel using some 320 grit sandpaper. This is the ebony disc that was previously rounded on my Pysanky lathe. This is the final cutting operations on this ebony disc. Not only is the surface rounded, but I also made the design cuts about 1/10 of an inch deep. This deep cut provides for a more visible pattern. After cutting, I lightly sanded the disc using the floppy wheel sanding disc. I then used the set screws to release the wood block from the faceplate. Here's an overall review of the results of producing 50 different patterns and wood samples for this video using the new automated Rose Ornamental Lathe. I used a number of different rosettes and Rosette Patterns for this testing. I personally like these patterns with alternating phasing of the rings. For these design patterns, I alternate the phasing of each consecutive ring by half a phase and adjusted the spacing of the ring so that the next ring would just touch the previous ring. I plan on using this design pattern on many of my future Pysanky eggs. However, this pattern works best when I can get at least 5 or 6 rings. So it will work best on the sides of the eggs, but probably not the best option for the top and bottom of the eggs. For the top and bottom of the eggs, I'll be using simpler design patterns, such as these design patterns. In producing many of these examples, I use a rosette with less segments for the inner rings. When cutting the inner and smaller diameters, you cannot cut as deeply into the wood as when you cut the outer diameters. If there are too many segments or loops, the cutting tool will obscure any pattern that was created. For example, in some of these examples, I use an 18-segment rosette for the outer cut patterns, and I used an 8-segment cutter for the innermost rings, and made these cuts shallower. This will create the center star pattern, as seen in these examples. I also use the universal cutter to make this pattern example. It gives a much simpler pattern, which I may use for the top and bottom of some of the eggs. But for most of my egg projects, I still plan to use a spindle motor with a smaller cutter in order to produce some more detailed cut patterns. Here's an example of a single-phase cut design. Both of the examples were made with the same rosette. I first made the pattern shown on the right. I then reduced the spacing between the rings and to cut the pattern deeper into the top surface, as shown on the left. Again, this demonstrates the variation design that can be achieved by just changing the spacing of the rings as well as the depth of the cut. On some of my patterns, I use multiple rosettes to produce some more complex design patterns. I also use an indexing technique to add some circular indentations to these designs. Due to the endless number of designs of rosettes and the various cutting techniques, the number of design possibilities is infinite. In this study, I also wanted to compare closed-grain woods versus open-grain woods. When creating patterns on closed-grain woods, such as ebony and cherry, I was able to produce very smooth cut patterns with no splitting or tearing out of the grain. The outer surfaces, as well as the cut surfaces of the pattern, can easily be sanded to a polished surface using a floppy disk sander. The results of cutting very coarse grain or open grain woods, such as oak and mahogany, turned out much better than I expected. The surfaces are definitely rougher due to the coarse open grain of the wood, but I did not see any noticeable splitting or chipping of the wood in either of these examples. I cut a total of 50 samples for testing, and only saw chipping on one sample in this study. This chipping occurred in one of the multi-layer samples, in which I used purple heart on the top layer. Only one small inner protrusion split out in this example, as seen here. When comparing the cut patterns on flat surfaces versus curved surfaces, I definitely preferred the patterns created on curved surfaces. I did need to make these cuts deeper for the curved surfaces due to the slope of the surface. The cuts are deeper on the edge closer to the center of the pattern and shallower on the outer edge, but I do prefer these deeper cuts. Next, I do like the multi-layered examples. For these examples, I cut thin veneers of contrasting colors and then glued the layers together. These multi-layered discs permit the easy viewing of more complex and smaller design patterns, since cutting through the top layer exposes the second layer. However, this does require very sharp pointed tipped cutters. Wider cutters or rounded cutters will not work as well with these multi-layered woods. Also, this works best for flat surface projects. My first observation that it's very difficult to see the cut patterns on highly figured or pattern grain wood samples. This one example here of a dizzy pattern block, it's near impossible to see the cut patterns. Right next to this example is a zebra wood sample, and once again the highly figured grain of this wood sample makes it harder to see the cut patterns on the face of the wood block. So my conclusion is that it's preferred to use wood surfaces with little or no grain pattern surfaces. The original purpose of the study was to determine what parameters would give me the best results for adding design patterns to the wood-turned Pysanky eggs. I plan on using the Spindel Motor cutter for most of these design projects. I prefer the fine tip cutters, which give me more intricate patterns, but I'll also be using some wider cutters when I want a more pronounced tapered appearance for these design patterns. Also, I still need to do some additional experimenting with some other cutters, such as cutters with a round ball end. The patterns that I prefer for the sides of the eggs will be designs with multiple phase rings, with each ring just touching the previous ring. But I've also been using some other patterns, especially patterns generated with multiple rosettes, which will create more complex designs. For the top and bottom of the eggs, I'll be using some simpler patterns, using both the Spindel Motor cutter as well as the universal cutter. I also prefer using the designs produced with curved surfaces and also deeper cuts, which produce more pronounced and visible patterns. As far as the selection of woods to use for these projects, I'll be using pretty much any wood, as long as there's not too much of a grain pattern on the surfaces of the wood. The other technique that I'll be using is creating the multiple layer carved disc, and then cutting a cavity into the side of the egg to insert these discs. There's an infinite variety of designs that I'll be using for the Pysanky eggs that I'll be producing in the future. As part of this study, I designed and produced a number of jigs to hold the eggs onto the Rose engine spindle. There are several new planned videos that will describe the design, the production, and application of these new Rose engine jigs. These videos should be available in the next few weeks. Once again, thank you for watching this video. If you have any questions, concerns, or comments, please leave a comment below or send us an email, and thank you.